The last thing I have to show you today is fairly algebraic. This is my the material I'm covering actually out of college algebra. There's a topic in college algebra where we or part of what we do there is we graph piecewise functions, and kids hate this because you can hardly do it on your calculator. I mean, you can do it on your calculator, but you have to know how to do it on your calculator. You have to be pretty adept at using your calculator to pull this off. And it's confusing to students, and they don't really understand why we need to do this anyway because they can't think of a good use for it. I want to show you a good use for it. Okay. First, I should tell you exactly what I'm talking about. A piecewise function has different output rules depending upon which values you put in. So, for values in this case less than a, I would use this rule, and for values between a and b, actually including a and b, I would use r sub 2, this rule, and then for x greater than b, I would use this rule. Okay, but kids get confused because they graph this thing across the, they're used to graphing things across and all the way across. They're only defined for certain portions of the real number line, of the x-axis. So it takes a little bit of practice to get good at graphing those on your calculator. The example I'd like to show you involves the US Postal Service. They distinguish between packages, large packages, and oversized packages. And the way they do that is they take a look at two values of the box that you're sending, the length, which is the longest dimension. In this case, in this picture, it would be the up and down dimension. And then they measure the girth, which is the perimeter of a cross section. This runs perpendicular to the length. So if the length is this way, the cross section would be this way, and you'd measure that perimeter. And they use a thing called length plus girth. And that you're just adding them together. So if the length plus girth is less than 84, there's a certain rate they will apply. If it's between 84 and 108, they call it this is package, this is large package, and there's a different rate. And then this is oversized package, and it's an even higher rate. And I made these numbers up. These aren't US Postal rate things, but these numbers are actually the accurate numbers. Now, what I'd like to do is put myself in a situation where I have to determine, and this is possible. I mean, if you're doing this, say you have a business and you have to send things to folks, you don't have your own trucks to deliver things, you have to mail them, then this might be something you want to worry about. I want to determine the cost per package to ship a package of weight W pounds. Okay, so W in this case is my weight. And I'm looking for information here about, okay, what would be the ideal weight that my packages should be so that I don't waste a lot of money here. The whole idea of being in business is to make money. So I want to do things in a nice, efficient, cost-saving manner. Okay, so I'm going to make some assumptions to make this a little easier. I'm going to assume that we're using a square package. That's not a wild assumption. That'd probably be the one that would maximize volume, but yet minimize the surface area, and they're probably easy to find. That automatically tells me then what my LPG is. It's the perimeter, which is 4x, plus the length, x, so that's just 5x. It also tells me the volume, which is just x cubed. All these dimensions are the same. I'm calling it x. So that gives me a little bit of information right there. I'm also going to assume that things are the weight of the things I'm putting in these boxes is about 1 ounce per cubic inch. Okay, that's not terribly heavy, but could be fairly heavy. That will enable me to then calculate the weight in terms of this x. Here's the volume, and then for each cubic inch of volume I have, that'd be an ounce is 1/16 of a pound, so it's just that formula. And I'm also assuming that there's a flat fee per package. No matter what it weighs, they're going to charge you this $2.90. Okay. The cost then for sending a package of weight W is, okay, you take the weight times the rate, and that rate depends on the weight. So that's not multiplication, that's function notation. And then you're going to add $2.90. Now here is the issue. This thing, this R, this rate, I don't have that in terms of W. I have it in terms of LPG, and I'm using these kind of cooked up numbers. I do have the LPG in terms of X. I do have the weight in terms of X. So I need to get this rate thing in terms of weight. So I'm going to bridge the gap by doing this. This is invertible. I can say W in terms of X, or I could say X in terms of W. Multiply both sides by 16, and then take the cube root of both sides. Then I can take this X, put it back in my LPG formula, and that means that the LPG is 5 cube root of 16W. Now I can take this and replace it in this formula. The only thing that I have to worry about is I'm getting this kind of ugly business right here in these inequalities, and I'd like to just have W. So I need to do a little solving. This is messy, but don't confuse, this is a big mistake, don't confuse messy with difficult. Messy is real life. The real world is messy. Difficult is, that means the theory behind it's hard, or the concept, or how to make it work is hard. We're just doing some basic arithmetic here. It's not difficult, it's just a little messy. Okay, let's go back. I would need to solve this inequality for W. So I'd divide both sides by 5. I would cube both sides, get this kind of ugly number, and then divide by 16. So that's the right-hand side of my first inequality. And then really you just kind of do that with all of these. The other is bounded by 108, the other one's bounded by 130, so you can get these bounds on W. And I only did one side because these are repeated, okay? So I'm ready now to get the cost function. It's weight times R, so I just took W and I multiplied times each of these rates in here, and then plus the 290, the flat rate. And so this is now, this cost function is a piecewise function, which I'm going to graph for you. Okay. If it gets out past almost up to 1,100 pounds, then it's getting too big to ship as even an oversized package, so I have to stop. But you can notice that there's some breaks in this map, in this graph. And if you're in this 630 range right here, then that's a good indication that you need to be careful, because you can ship a package that weighs 625 pounds at this rate, which is fairly low. Or you can ship something that weighs 630 pounds at a much higher rate up here. So if I'm trying to save money, right, it's to my advantage to stay below this number and not have to pay this extra high fee right here. Okay. Good example of how you want to do this kind of analysis of your business practices to try to save money, and it involves piecewise functions. The things that I flashed up there were pretty quick, so let me put a summary page up that talks about what I talked about.